Given question, block A weighing 500 Newton rests over block B which weighs 1000 Newton. Block A is tied to a wall with a horizontal string. If the coefficient of friction between blocks A and B is 0.25 and between B and floor is 1/3, what should be the value of P to move the block B if first P is horizontal, second P acts at 30 degrees upwards to the horizontal.
There are two cases. We have to find out the applied force P when the direction of force P is horizontal, and second case when the direction of force P is inclined. We will consider the first case when P is horizontal. And now we have to draw the free body diagram. We will first consider the block B. This block B is in contact with the lower fixed surface. So there is normal reaction N. Now we will consider here the suffix 2 for the lower surface of the block B. So we will show here the normal reaction N2 which will act in perpendicular direction of this surface, and direction is towards the block B, and this normal reaction N2 is passing through the center of block B. So we have to show this. So here is N2. Now we have to show applied force P. So we have to show in horizontal direction towards the right hand side. Now we have to find out the value of P in such a way that this block B will move in the direction of the applied force. Now when it starts moving, then the frictional force develops. So this lower surface of the block B is in contact with the fixed surface. So frictional force we have to show in opposite direction to the motion of the block B. So here we will use suffix 2, that is F2. Now there is the weight of the block B. So this weight is equal to 1000 Newton. So we know that the weight always acts in vertically downward direction passing through the center. So here 1000 Newton. Now when the block B start to move in the direction of the applied force, that is towards the right hand side direction, then its upper surface also in contact with the lower surface of the block A, and therefore there the frictional force develops, and which is also in opposite direction of the motion of the block B. So we have to show here the opposite direction of motion, and this time for the upper surface we will use the suffix 1, that is here frictional force is F1. Now we will move to the block A. Now block A is in contact with the block B. So again there is the normal reaction N which is in the perpendicular direction of the surface of contact. So this surface of contact is horizontal. So we have to show normal reaction N1 which is perpendicular to the horizontal and passing through the center. So here is N1. Now this upper surface of B is also in contact with the lower surface of A. So this N1 also acts on the block B but in opposite direction. So we have to show here N1. So I will show this N1 which is in opposite direction. So its a magnitude is same but direction is opposite. Now this frictional force related to block B is in the opposite direction, and now this upper surface is in contact with lower surface. So here also frictional force develops, which is the magnitude is same but direction is opposite. So we have to show same frictional force F1 but we have to show opposite direction. So here F1 towards the right hand side. Then weight of this block A. So weight always acts in vertically downward direction and it is equal to 500 Newton. Now there is the string which is connected to the vertical wall. Now this vertical wall is fixed. So we have to show the tension is created in the string and which is in the outward direction from the block. Because this surface, vertical surface is fixed surface. So we have to show tension created T which is outward direction of the block. So this is the free body diagram. Now we have to find out this applied force P. So we will first consider the equilibrium of block A. Now for equilibrium of block A, we have two conditions: summation of forces in vertical direction is equal to 0 and summation of forces in horizontal direction is also equal to 0. So first we will take summation of Fv is equal to 0. Now if we observe here, there are two vertical forces N1 and 500 and both are in opposite direction. So we can say that N1 minus 500 is equal to 0, or from diagram we can directly write N1 is equal to 500. Then here is frictional force F1, and which is the limiting friction. Now there is one relation in between this frictional force and normal reaction N1. So the ratio of F1 by N1 is known as coefficient of friction, and this coefficient of friction is mentioned in the question in between the block A and block B. So in between the surface of block A and block B, it is 0.25. So F1 by N1 is equal to 0.25. Therefore F1 is equal to 0.25 into N1. N1 is 500. That is equal to 125 Newton. Now we will move to the next. Summation of all horizontal forces is equal to 0. So from diagram, F1 and T both are in opposite direction. So from diagram we can directly write F1 is equal to T, that is tension in the string. So F1 is equal to T, and which is also equal to 125 Newton. Now we will move to the block B. So when we consider the equilibrium of block B, then summation of all vertical forces is equal to 0. Now which are the vertical forces? So from diagram we can say that N2, N1 and this weight 1000 Newton. So this N1 and 1000 Newton is in downward direction and N2 is in opposite direction. So we will say that N2 minus N1 minus 1000 is equal to 0. Now from block A we have calculated N1, and which is equal to 500 Newton. So N2 is equal to 500 plus 1000, which is equal to 1500 Newton. Now we will calculate the frictional force F2. So there is relation in between F2 and N2. So F2 is the limiting friction. So F2 by N2 is equal to coefficient of friction in between this block B and surface, and it is given 1 by 3. So F2 is equal to N2 multiplied by 1 by 3. That is 1 by 3 into 1500, which is equal to 500 Newton. So value of F2 is calculated. Now we will take summation of all horizontal forces is equal to 0. So horizontal forces from diagram we can say that F1, F2 and P, where F1 and F2 is towards the left hand side direction and P is towards the right hand side direction. So we can say that P is equal to F1 plus F2. So this F1 is calculated from the block A and F2 is also calculated. So P is equal to 500 plus 125, which is equal to 625 Newton. Now we will move to the second case when the applied force P is inclined at 30-degree angle to the horizontal. Now in this case, when we draw the free body diagram, then for the block A the free body diagram will remain same, but for the block B we have to show applied force P which is inclined at 30-degree angle. So when we take the equilibrium of this block A or block B, then we take summation of all horizontal forces is equal to 0 and summation of all vertical forces is equal to 0. So for that case, we have to resolve this inclined force P in horizontal component as well as in vertical component. So we will show here. Now how to define its value? Now if we observe this horizontal component is nearby to angle 30 degrees. So its value is P cos of 30, and for vertical component P sin of 30. Now we will move for the equilibrium of this block A. So as we have solved in earlier case, same steps we have to follow. Summation of all vertical forces is equal to 0 and therefore N1 is equal to 500 Newton, and summation of all horizontal forces is equal to 0, F1 is equal to T. So from the relation N1 and F1, that is F1 by N1 is equal to 0.25, we will calculate F1 125, and therefore tension T in the string is also equal to 125 Newton. Now when we calculate the equilibrium of this block B, then we have to use the value of N1. So N1 is 500 Newton. So we will take here N1 is equal to 500 Newton because N1 is related to this block B, and we have to also consider this F1 because F1 is also related to block B. So it is 125 Newton. So we have to note that F1 is equal to 125 Newton. We will move to the next block B. We will consider the equilibrium of block B and summation of all vertical forces is equal to 0. So which are the vertical forces? N2, N1, weight 1000 Newton and this P sin 30. So we will take here N2 plus P sin 30 is equal to N1 plus 1000 because these are in opposite direction. So N2 is equal to 1500 minus 0.5 P. Because we know that the value of N1 is 500. So this 1000 plus 500, that is 1500, and P sin 30 is 0.5 P. Now F2 is the limiting friction and there is one relation in between F2 and N2. So F2 by N2 is equal to 1 by 3. So F2 is equal to, so we will take this divided by 3 which is equal to 500 minus 0.5 by 3 P. Now summation of all horizontal forces is equal to 0. So how we can write? So from diagram, this P cos 30 is equal to F1 plus F2. Now this F1 we have calculated in previous case 125 Newton, and now this 125 plus this F2 500 minus 0.53 P is equal to P cos 30, that is equal to 0.866 P. Now we will take P terms on the right hand side and all the other terms to the left hand side. So when we simplify it is 625 is equal to 1.032 P, and therefore P is equal to 605.62 Newton.